Now we will discuss some questions relating to real numbers. Previously we have read that root 2 to be a rational number, root 2 is a irrational number, and for this proof we have taken that p to be a, let p to be a root to be a rational number, then we arrive at a contradiction, then we will conclude that root 2 is irrational. So whenever p is an prime number, root p is always irrational. So we have to, in the next chapters or next questions anywhere else, whenever we come to a root p, p is prime, we will take that it is irrational. Every time the proof is not necessary. The things which is given to be proved, only that will be proved, not individual root 2, root 3, root 5 to be proved as irrational. It is constitute that it is irrational. We should take that. So let us come to this example. Prove that 7 root 5 is irrational. Assume that 7 root 5 is irrational. That is the standard process. Then we will come to a contradiction. Rational in the form of p by q. What is the form of rational number? P by q. Pq belongs to q I and q is not equal to 0. So 7 by root 5 p by q. So 7 root 5 is equal to p by q. This implies root 5 is equal to p. 7 is divided in this side q. Now here p belongs to I, q belongs to I, not equal to 0. So in total it is again in the form of p by q form, where 7q is some s, suppose s, 7 by qs. So it is p by s form. So again it is in the form of p by q. So again a rational number. So root 5 is a rational number, which is not correct. It contradicts. So here we have not need to prove root 5 is irrational in detail. Only you assume or take that root 5 is irrational. We know it because 5 is an prime number. So you took it as root 5. Now come is a rational, which is false. Why it was false? We have taken 7 root 5 to be rational. So now we conclude that 7 root 5 is not rational. So what is the alternate? If a number is not rational, I have told earlier that if a number is either it will be rational or it will be irrational. If it is not rational, then it will be irrational, the only alternative. So 7 root 5 is an irrational number. So it is proved. Now the second question. In this question we will discuss in a speedy method. Otherwise we will not cover 20 to 30 questions within the short period. So come to this question. If two integers a and b are written as a is equal to x cube y square and b is equal to x y cube, x y are prime numbers. Because whenever it is in the written as, suppose it is 2 square into 3 square, not we can write this square into 6 square is another number. Always we have to write in the form of their prime factors. So 2 has prime factors. So always write or express in a prime factor. So a x cube y square, it is in the expression with x is prime and y is prime. So it is in this form, b is this, x, y are prime numbers. Then HCF b is equal to LCF. Now is asked to find out the HCF and the LCM. Earlier we have told during the theorem, where we are reading the theorem, HCF is equal to the lowest factor, common lowest power of factors common in both. Here we come to this x cube y square, x y cube. Take x cube y square, x y cube. So common is x. Here is common is y. But the lowest factor, lowest power, x and x cube, the lowest factor, lowest power, lowest power is x to the power 1 or x. Here in y square and y, x cube, x. lowest factor is x. Y square, y cube, lowest factor is of y is y square. So HCF will be consider the on the lowest factor, x y square. So x y square will be the HCF. Come to the LCM. What about the LCM says? You see that LCM, the highest power. So hold it. नहीं सेटा हलुन एटा हलुन हाईएस्ट पावर ऑफ x square is x cube, y square y cube is y cube. So LCM will be x cube y cube as no other factors are there. It is proved here. So x cube y cube. Now another question. The prime factorization of 3 to the power 13 minus 3 to the power 10 is. Actually this can be expressed as, we need not multiply in detail, but only to use some formula. We written that 3 to the power 13 minus 3 to the power 10. So by the process of common, take 3 to the power 10 as common. Then this will be, we know that a to the power x into y is equal to a to the power x into a to the power x plus y, e to the power x to y. Whenever the base is same, the power will be added. So if x plus y is equal to 3 to the power x to the power y. So if 3 to the power 10 is there, 3 to the power 13 is given, another 3 to the power 10. So we can express this 3 to the power 13 as 3 to the power 10 plus 3 minus 3 to the power 10. Now again apply this, a to the power x plus y is equal to a to the power x into a to the power y. So we can write this 3 to the power 10 into 3 to the power 3 minus 3 to the power 10. Now this can be taken as common. So it is 3 to the power 10 into 3 to the power 3 minus 1. 3 to the power 3 minus 1. So it is now easy. 3 to the power 3 we can mentally calculate it. 3 into 3 9 into 3 27 minus 1 26. 3 to the power 10 26. Now power 3 to the power 10. You need not multiply in detail, only give it shortcut way. 3 to the power 10 into 2 into 13. It is expressed in the, you need not find out all the final result. What is the power of 3 to the power 10? 3 into up to 10, it will take 15 minutes to calculate this. He only asked in prime factorization. It is not a prime factorization, it is a composite number. You break it into 2 into 13. But 3 is a prime factor, whatever the power may be. So it is now in the form of power factorization. What are the prime factors? 3, 2 and 13. What are the powers? 3 power is 10, 2 power is 1, 13 power is 1. So it is a final position of the prime factorization. Now question number 4. If least prime factor of 5p is 5 and least prime factor of q is 7, then the least prime factor of p plus q is this. So it is somehow is a technical question. It is some IQ. You have to apply some IQ or thinking power or imagination. First you read it twice. Read the question twice. What it is given. If least prime factor of p is 5, least prime factor of p is 2. So it has a prime factor p is equal to 2. Then other prime factors may be there, 3, 7, 83, 97, whatever that may be. But the minimum is 2. So that p has a prime factor of p is 5. So if least prime factor of p is 5. So least prime factor of p is 5. So whenever you will factorize p, you will start from 5 into dash dash dash, because list is prime. Thereafter any other numbers will be there. Similarly, q, it has also the least prime factor is 7. 7 into something else. So it is starting from 5 factor, it is starting from 7 factor. Thereafter other prime factors are also there. Then the question says that then the least prime factor of, whenever you will add these two, p plus q, a number, what will be the prime factors? What will be the prime factors? Now it will come in details. We know that the least prime factor is 2. If least prime factor of p is 5 and least prime factor of q is 7, then the least prime factor p plus q is. We know that the least prime factor in our cases of prime numbers are 2, 3, 5. So what can be the least prime factor? If you are factorizing something, a number, what will be the least? It may be, may not be. Here it is not there. 2 and 3 is not here. 2, 3, 5 is not here. But 2 is the least prime factor. It may be here, it may not be here. It does not matter. But always 2 is the least prime factor of any number. So is a prime factor. A even number can also have a least prime factor too. What is an even number? Even number, it is 2m plus 2n. Whatever m may be 3, m may be 7, or m may be 4. If 2 is multiplied, always it is a even number. Now you come to this. 5 is a factor, 7 is a factor. So whether if you add this will comes to 12. No, this will comes to even number p can also be least factor, prime factor. Since given that both p plus q have least prime factor other than 2, i.e. 5 and 7, it is obvious that p and q are not even numbers, means they both. So least prime factor is 5. So whenever the least prime factor is 2, if you will multiply with any other prime number, it is always prime. Only if 2 is there, then it could have been an even number, because 2 is a prime number. Otherwise, except 2, if you multiply any prime number, p1 into p2 into pn, whether it is prime or even, it is always even or odd, it is always odd. Because inside this number, no number is an even number, because it is prime. Even number is a not prime, except 2. We have left 2 outside. So if you take from 3 to onwards, then every time whatever you multiply it, it is always an odd number. So p starts multiplying from 5. So whether it is even or odd, it is an odd number. So p is an odd number. Similarly, q multiply starts from 7 factor. So it is also an odd number. When two numbers are added, p plus q, what will happen? Odd plus odd is odd plus odd is always even. You know it very well, because from the general point of view or from mathematical point of view, just p, a odd number can be written as 2n plus 1. Another odd number is 2n plus 1. When you add this, 2n plus 1 plus 2m plus 1, that is equal to 2n plus 2m plus 2. Everywhere there is a factor 2. So it is an even number. Factor 2 means it is an even number. So when two odd numbers are added, it will be a even number. So even number means, what is the minimum prime factor? 2. For every even number, the minimum prime factor is 2. So the question is asked, then the least prime factor of p plus q. So the least prime factor is 2. So answer A is correct. Obvious that p and q are not even number more than both. So odd 2 is the least prime factor. So answer 2 A is the correct answer, because odd plus odd is even. Even means it is a factor of 2 and that is also least factor. Now come to the question number 5. If 6370 is equal to 2 to the power m 5 and 7 k 13p, then the value of k. So it has written that it is prime factorization. So obvious that when this is expressed as 2 to the power something into 5 to the power something into 7 to the power something into 13 to the power something, that means it has prime factors 2, 5, 7, 13. It is obvious. Only the factor, suppose one number is written 2 into 2 into 3. It is 2 to the power 2 into 3. Now it is similar 2 to the power m. We can express m as 2. So, but the factor is 2 and 3. Factor is 2, 5, 7, 13. But they are powers. Powers means we will write the details powers. How we will find this? We will by the method of factorization. We have earlier classes we have read about the method of factorization in this way. We have read in your earlier classes. First, it is 0 means it is divisible, even number divisible by 2. Start from 2. It will be easy. It may take some 1 or 2 minutes extra, but you will get the concrete answer. There will be no mistake at all. 2, then again 5 means division by 5. Then 7, just you come to 7. You mentally prepare, calculate this 7, 9, 7, 1, 91, then 7, 13. So we can write this as this. 3 to the power 1, 5 to the power 1, 7 to the power 2, 13 to the power 1. So you come to this. 3 is a factor. 3. It is not 2, it is 3. Okay. It is 3. No, it is 2. 2. Okay. 2 is there. 2. It is only mistake is here. 2. Okay. 2, 5, 7, 13. 2, 5, 7, 13. 2 to the power 1, 5 to the power 1, 7 to the power 2, 13 to the power 1. So what is the value of now 7 power h 2? What is the value of k? K is 3, k is C. So this answer C is true. So it is nothing, just a previous imagination of whatever read about in your previous classes. Just it is a revision, nothing else. The largest number which divides 6 to the power 13 and 960, leaving a remainder 6 in each case is. So what will find this? Whether we will find the LCM or find the HCF, what we will find this to get the answer. Now it is given that the largest number which divides 6, 15 and 963. So the number will, suppose the largest number is, let the largest number be x. When x will divided by 615 by x, 963 by x, leaving a remainder, here the remainder will be 6, here the remainder in each case. Now we think that if whenever you are dividing x, you are getting a remainder 6. Whenever dividing, in this case also 6. If you will deduct 6, will be there in remainder. Suppose you are dividing 12 by 2, 12 by 19 by 6, your remainder 1, or 23 by 6, your remainder 5. If you will deduct that remainder, 23 minus 5 is equal to 18, will be there any remainder? It is divisible by 6. So the numbers are 615 and 963. When you are dividing this with any factor, always there will be a remainder 6. Then if you will divide that 6, deduct that 6, there will be no remainder. Now the number x, where x divides is, the remainder is 6. implies 6 is greater than, and that fundamental thing is the remainder must not be less than the divisor, because it will be, if you are writing it is 1, it is 7, it is not possible. If possible you are writing 6, 7, how it is possible? Remainder 7? No, because you are dividing by 6. Another one division is there. Then the remainder will be 1, but not remainder will be 7. So always x is greater than the remainder. And if 6 is deducted from 615 and 963, no remainder will be there. That means the HCF of 6 and HCF is the factorization method. Now we will first deduct. Now you will deduct, you are coming to 615, 69, and this division is 957. Now the HCF of this. So what is the HCF? What is the HCF? The highest number will divide with this. You come to this process. If you are taking division by 3, whether it is divisible or not. Because if you divide 3 with this one, you will get 203. If you are dividing by 3, 319. Will be it the answer 3? No, because it is not the highest. Besides 3, there is a higher number which also divides the both two. What is this? When 29 is divided, it gives 7 and 11. Thereafter, there is no number. So, if you are multiplying 3 and 29, that will be the HCF. It is not the highest. 3, just you elaborate now this. 609, 957. You see that by 3 it is also divisible. By 3 it is also divisible. Another time you see that by 29 it is divisible. By 29 also it is divisible. Is it highest? No. Is it highest? No. But when you are multiplying this, because it is also factor, it is also factor. So their product is also a factor. It is obvious. So 3 into 29, thereafter there is no common factor. So this will be the HCF. Neither 3 nor 29, but 3 into 29 is the HCF. So that is the result. So 87 is the correct result. Now if minus n plus minus 1 to the 4 to the power n is equal to 0, then n is any integer, any even natural number, any positive integer, any odd natural number. Now we will come in detail. How we will solve this? But what you are expecting from this? What the question says? The question says one is minus 1 to the power n, another time is minus 1 to the power 4n. The minus 1 in both cases are same. Once the power is n, another the power is 4n. N is any natural number. Any natural number, then n is any integer. No, he is asking to find out. This is equal to 0, the summation is equal to 0. Then we will find out what will be the nature of n. What will be n, you will get this result. You come to this. Suppose minus 1 to the power n, minus 1 to the power 4n plus is equal to 0. We leave this n. First, minus 1 plus minus 1 is not 0, because minus 1 is equal to minus 2. So it is not for all n, it is not always true. So once if this will be plus, this will be minus, or if this will be minus, this will be plus. Only at this case, plus 1 minus 1 is equal to 0, or minus 1 plus 1 is equal to 0. So either this will be minus 1, then it will be 1, or this will be 1, it will be minus 1. Then in which cases it is possible? This is our thinking. Now it is clearly mentioned here. We know that any power of 1 is always 1, because 1 to the power n, you multiply as many as times 1, always the result is 1. But when minus 1 is multiplied, it will not give the result always minus 1. 1 is multiplied as many times, 1 to the power n, 1 into 1, into 1, as many times it is always 1. But in case of minus 1, two times positive, 3 times negative, 4 times positive. So, whether n is odd or even respectively, if n is even, it is plus. If n is odd, it is negative. If n is even, it is positive. But for this, there is no restriction. It is always even. But we are given minus 1 to n plus minus 1 to the 4n. But one thing is that for n is always positive. For n is whatever n. For n is always even or odd. 4 into n is equal to 2 into 2n. Whatever this may be, we leave this. But it is also even. But 2 is multiplied when this number is always even. So if it is always even, then what will be this result? Minus 1 to the power even power. We read this. Always even means it is always plus 1. Now, we need this to be negative, then this summation will be 0. So, minus 1 is even, minus 1 is to the power n. N is even, minus 1 even. It will be 1. This also even number, it is also 1, is not equal to 0. So, when it is even, there is no chance that this sum will be 0. Only in case of odd, that may be. Now verify. If this is odd, this n is odd or even, whatever that may be, 2n is always, 4 to the power n is n even or odd. Does not matter. But 4 to the power n, for n is always even or odd? Even or odd? It is always even, because 4 is multiplied. Whatever n, suppose n is 3, n is equal to 3. 4 into n, 12, even. Suppose n is equal to 7, 4 into 7, that is 20, even. So, whatever the case may be, n, even or odd, it is always even. Now take the odd. If you are taking the odd number, it is even. So, minus 1 to the power even, minus 1 to the power even for n, always positive, and minus 1 to the power n, always negative. Positive 1, it is minus 1. At this case, their summation will be 0. So, what you conclude? We arrive at that always not any integer, not possible. Any even natural integer, false. Any positive integer, any odd natural number. This is the only case. In other 3 cases, it will not happen. Only when it is an odd natural number, fraction is not possible, or rational number 2 by 3, 4 by 5. We cannot take the power of 1 to the power 4 by 5. We cannot get in this way. Always n belongs to n. So, D is the correct answer. Just for your reference, we have written this. Minus 1, minus 1, 1, minus 1, minus 1, 3 factors. It is 4 times. It is 2 times. Okay. Now, question number 8. If n is any natural number, then 6 to the power n minus 5 to the power n always end with 1, 3, 5, 7. How will you solve this? Prior to solving this, you can spend 1 or 2 minutes by taking n is equal to 1 or 2 just for reference, or you have to acquaint with the question. 6 to the power 1 minus 5 to the power 1. 6 minus 5. 6 minus 5 is equal to 1. One digital number, unit plus 1. 6 to the power 2 minus 5 to the power 2. 36 minus 25 is equal to 11. Say unit plus 1. So from these two we come to the unit place is 1. So what will be the any natural number? So 3, 4, 5, 3 it will be obvious. But in which way we will generalize the thing? It is in mathematics we are not giving that we have tested for 10 numbers or 10 things. So it is correct for a crores and crores number. It is not like that. We have to arrive at a general formula. For reference we are just verifying for 1 and 2, but it is not for n is 1 true, n is 2 true, so it is true for all n, not like this. But we have to come to a general formula. Now this is elaborated here, written that. We know that for any natural number n, 6 to the power n with the digit 6, because 6 to the power n is equal to 6 to the power 1, 6 to the power 2, 6 to the power 2. For any power you take 6, always the unit number is 6, because 6 into 1 is equal to 6, 6 square into 6, 36, 6 into 6 into 6 is equal to 36 into 6, again 6 into 6 unit place 6, 6 into 6 unit place is 6. Again when you multiply for any power of n, any power of 6, always the unit place is 6. One thing is confirmed. Again you come to the case of 5. 5 to the power n. 5 to the power 1, 5. 5 to the power 2, 25. 5 to the power 3, 125. Always the unit number is 5. For any number, it is not for 1, 2 only. For any n, with 6 to the power n, the n digits with and the n digit is 6. For 5 to the power n, always the n digit is 5. Whenever you subtract this, what will be? 6 minus 5. Suppose whatever the number, end point is 6. Another point, whatever the number, 2 digital, 5 digital, 10 digital, 1 crore digital, does not matter. The unit place is 6, the unit place is 5. When you are subtracting this, always you get the unit place is 1. That was the question. Always, so what will be the answer? The answer will be A. So A is the correct answer. Okay, it is now generalized. The question number 9. If A and B are co-primes, then A square and B square are co-primes, not co-primes, even number, odd number. Solution. Since A and B are co-primes, they have common factor only 1. Also in previously I have told this during the proof of root 2 is an irrational number. What is the meaning of co-primes? If there is the lowest, either in you can say it is in their lowest form or it is in the highest common factor is 1 only. Means they have no common factor at all. If we take A square by B square is equal to A into A by B into B, this is equal to A by B into A by B. They also have the same common factor 1, because it has common factor 1, it has common factor 1. A by B has common factor 1, A by B has common factor 1. When this will multiply 1 into 1 is equal to 1, they will common factor 1, no other common factor. Question of any 2, 3, 4 factor will arise. The question does not arise at all. So also have the same common factor 1 implies A square, B square have also the co-primes. So A is the correct answer. So A is the correct answer. Again it will be a co-prime. Whatever A and B may be, you take any and B, any form. Suppose 4 by 5. It is co-primes. Then A square by B square is equal to 16 by 25. Obviously it is co-primes, because 4 by 5 into 4 by 5 is equal to 16 by 25. They have common factor 1, they have common factor 1. Now you just change your imagination thinking. 4 by 12, suppose 4 by 12, it is not co-primes. 4 by 5 square is that is equal to 16 by 144. 16 by 144. What is the common factor? Was only 2. Here the common factor was 4. Square is common factor 9. 1 by 9. So the common factor is 16. Very clear. When it is 4, its square is 16. Common factor is, it is not a co-prime. If the common factor is 1, its square is 1. No problem. Again co-primes. But if there is a common factor 2, their square has common factor 4. If the common factor is 2, it is not co-prime. If the common factor is its square 4, it is also not a co-prime. Only if it is co-prime, then their square or their cube or whatever the power you take, it is always a co-prime. 3 bulbs, red, green and yellow, flash at intervals of 80 seconds, 90 seconds and 110 seconds. All these 3 bulbs flash together at 8 am. At what time the 3 bulbs flash together again? It is a question of either we have to find out the LCM or HCF. In this question, generally it is asked in problems or in our day-to-day life, we may happen with these aspects. Suppose there are 3 bulbs, it is given the intervals of red, green and yellow. One is 80 second plus 80 second, 90 second. Suppose we are pushing the switch, then after some seconds it will flash. In the case of bar light, it takes some time. So it tells that one is taking 80 seconds, the other is taking 90 seconds, the other is 10 seconds. But if you are putting the switch, all the 3 bulbs flash together at 8 am. 8 am flash. There is a flashing at 8 am. At what time the 3 bulbs flash together again? Because there is a gap, 80 second, 90 second, 110 second. So first time it will flash at the same time. You are putting you are switching, or you are just put the apparament to the electrical apparatus or electrical switch. Initially they will flash at the same time, that it is given at 8 am. But next time it will flash at 8 am, 80 second. It will flash at 8 am. First, suppose at 8 am we switch on. It will flash the next time at 80 second, 8 minute 80 second, 8 am 90 second, 8 am 110 second. They will not flash at a regular interval. They will not flash at the same time, because there is a difference in the next flash. It will take 80 seconds, it will take 90 seconds, it will take 1 second. So there will be a gap of 10 and 20 seconds between them. So the question says that after what time they will flash again simultaneously as initially. Initially at 8 am they equally flash at the same time. So after how many times gap, there will be another flash, that they will flash at a time simultaneously. So it is the LCM is required. By the HCF will get nothing. HCF will give no result. Only the LCM it will give the result. After what time there will be a flash simultaneous. By that time it may flash 10 times, it may flash 9 times, it may flash 11 times. The minimum time taken will get the maximum flash. So it may flash 11 times, it may flash 10 times, it may flash 9 times. So we are getting this through the method of HCF or LCM. Whatever the case may, we will just elaborate now. Whether we will find out the LCM or HCF. Let at 8 am all 3 balls flash. Red will flash at 8:30 seconds, what I have told earlier, that is 8 am 1 minute 20 second, 1 minute 30 second, 8 am 1 minute 50 second. It is obvious that after certain time duration, red, green and yellow will flash on equal times, but because they will take different times, so their flash will not be at the same time because their time is different. Even if they will flash on equal time, but there will come a time when 3 bulbs flash simultaneously. After some gap of 1 hour, 2 hour, or 3 hour, whatever the time they may take, they flash again. Obviously, again, even though they might have flashed at different times, as I told earlier, it may be text 11 times, it may be 10 times, it may be 9 times, whatever that may be, but they would flash simultaneously again in the same time. So that time is asked to find out. Now, so let us take the LCM of 80, 90, 110. This is by the method of prime factorization. It is this second. Now it is 2 hours 12 minutes. Their LCM is 10, 8, 9, 11. We need to find in the prime factorization method. We should have done this, but to save time, suppose it can be written 2 into 5, it may be written 2q in 3 into 11, all these types, 2 to the power 4, 2 to the power 8, all these things. But not necessary to write in details, because to save time, we can write in a shortcut way. In this way also we can write this, because you come to this 80, 90, 2, 40, 45, 55. Again 2, 5, 8, 9, 11. So now the prime factorization is 2 into 5 into 8 into 9 into 11. 2 into 5 is written 10 here directly. So we can change this 2 into 5, no problem. Into 8 into 9 into 5. This is the LCM. Further, there is no possibility of any common factor within any two. For LCM, HCF is required for everywhere, there must be a common factor. But for LCM, maximum 2, minimum 2. If there is any common factor with minimum 2, then we can take the LCM. But there is no common factor within 8, 9, 11. Now, so this is total 132 minutes. 132 minutes means 2 hours 12 minutes. So what will be the time? After this LCM, after the gap of 132 minutes, everyone will flash at the same time. So what is the time? 132 minutes. 132 minutes, 2 hours 12 minutes. The initial was 8 am. Now you add 2 minutes, 2 hours, 132 minutes, 2 hours 12 minutes. 2 hours 12 minutes, 8 plus 10 to 10 hours 12 minutes, or 10 am 12 minutes. That is the answer. 10 hours 12 minutes is the correct answer. This is worked out by the process of LCM. Now come to this. If HCF of 65 and 137 is expressible in the form of this, then the value of m is, it is sometimes different from direct process of HCM, LCM. It is some typical type of a problem where we have to think something, or we have to increase our IQs. It has been asked. So it may not be asked in general cases, but still then we should go through all these things only to enhance your IQs, thinking power. So what should be done? You will add that. If the HCF of 65 and 17 is expressible in the form of, see, the HCF is expressed in this way. First you find out what is the HCF. 65, 117. This is 13 into 5. 65 is equal to this. 117 is equal to 5 into 13 into 11. 117 3 3 3 9 9 3 13 9 into 13 13 into 9. So what is the HCF? 13, because you can also write this 65 is equal to 13 into 5, 117 is equal to 13 into 9. So HCF is 13. Now thus 13 is equal to, if that you will express this way, express that HCF is, that 13 is expressed in the process of this. So it is nothing but an equation which we will read in the next chapter. But prior to this, we have read in previous classes. We can solve this. 65m is equal to 13 plus 117, that is equal to, so m is equal to 130 by 65, that is equal to 2. M is equal to 2. It is just a twist. It is directly process of HCF, but there is some little twist. Just you put the HCF 13 and find out the result of M by the process of solving of unvariable, only one, the variable M, which is read in the next chapter. It will be easier, but for the timing you remember this. It will be easier, somehow easier in the next chapter. If D is the HCF of this and this is expressible in the form of D is equal to 56x plus 72y, find the value of x and y where x and y belongs to y. It is another question. It is directly given that HCF is given in this form. It is said that HCF is given in the form of x and y, two variables, x and y. Now, for this, for any x you will get a y. What you put any x is 0, you will get a y. Put y is equal to 0, you will get a x. But what will be the fact? The fact is that we should come to a natural number. How will we get a natural, not a fraction? Suppose 56, 72. What is the D? Highest common factor. It is 8. You notice it is not necessary to find out always through this process. By your mental exercise, you can work out what is the HCF. HCF is 7 into 8, 7 into 8 into 9, 8 into 9. So 8 is the HCF. So this HCF is expressed in this way, 56 into 72. If we will now come to this, 8 is equal to 56x plus 72y. Put any value to x. Let x is equal to 0. What will happen? This will be 0. Then 72y is equal to 8. This implies y is equal to 8 by 72. That is equal to 1 by 9. If one is 0, the other is a fraction. Now we come to how we will get a natural number for both x and y. This is the main question here, or the main idea or main aspect of this question. For any value of x, you can get a y. For any value of y, you will get a x. But that may not be natural, that will be fraction like this. So how to get a natural number? So we have to use the long division of HCF. Long division, do you know about the long division process, which is read in previous classes or which is omitted, but for the time being, you should know this. It may become in use in future. What is this? Suppose 72, 56. First you divide 56 with 72. That is the process. The higher one will be divided by the lower one. That is 1, 56, 16. then this 16 take as an divisor, come this as a dividend. Now 16 for 3, 48. This is 6. This is 48, 16. Now this 16 will as a divisor, this will come to this. Now it is 48, 0. So possible. Now HCF is possible. It is 8 only. 8. This no more long division come again. 72, 56. It is 1. 56, 16. This 16 will divide with 56. 48. 8. This division here. The last divisor is the HCF. This is the long division method. Long division method. Long division method. Now, so you look to this now. It is given that among long division 72 is 56 into 1 plus the remainder. 56 is 16 into 3 plus the remainder. In this case, it is given, we will express in this form 56x plus 72y. So 8 will be written as 56 minus this into this. It is written. So 56 can be expressed now. 56 minus 72 minus 50, no, 56 is equal to this one. 56 is equal to 16 into 3 plus 8. This one. We took this one. 16 into 3 plus 8. 56. 72 is equal to 72, 56 into 1 plus 16. These two things is taken to this. In this case, the HCF is 8. We know earlier that HCF is 8. So let us take 56 is equal to 16 plus 3. 16 into 3 plus 8. This implies 8 is the HCF written here. D is equal to 8 is equal to 56 minus this 8 is kept here. 16 minus 3. This is taken to this side. Now we will express it as an 56 is there. 56 is there. Here it is 72, but it is 16 minus 3. Now try to transfer it or change it to 72. How will you read this? Apply this. 56 minus 16 can be written as in this way, not in another way. You can express 16. What is the value? 16. But why we write this? Now 16 is required. 16 into 3. 56 minus 16 into 3. Why we are writing this 16 as 72 minus 56? Why not as 16 can be written as 20 minus 4 is equal to 16. 32 minus 16 is equal to 16. Whatever you can write, so many ways, but we are expressing in this way because our question is in that way. 56x plus 72. There will be only 56 and the other will be 72. So using 72 and 56 we will express 13. It is obvious because we have written earlier. So, the 56 is equal to 72 56 plus 16. You apply this. 56 into 1, 56 is equal to 72 minus 16. 72 minus 56 is written as 16. Now, 56 minus 72 into 3, just to delete the bracket. 56, common is 56, 56, take the common 56, it is 1, it is 3. 4 minus 72 into 3 is equal to 56 into 4 plus 72 into minus 3, because it is plus sign is here, we cannot give the minus sign, plus 32. So what is the now x? This is x, this is y, x, y, verify x, y. What is the value of x, y now? This one. It is now natural number. Natural number, it is now integers, not fraction. So in other case we are getting fraction. In this case we are getting 0 fraction, but in this case we will get a whole number. That is integers, no fraction. That is a particular case, not in general. It is so many equations are there, because d is 1, it has 2 variables. In the next chapters you will that it has infinite solutions. So, but particular solution is 4 and minus 3, which is worked out by the process of long division of HCF. Okay. If n is an odd integer, prove that n square minus e is divisible by 8. It is another question. In the previous questions, it is also like that. Just you come across the details. Suppose n square, one example, just n square is minus 1 is divisible. Let n is equal to 3. The n square minus 1 is equal to 9 minus 1 is equal to divisible by 8. Suppose n is equal to 4. The 3 to the power 4 minus 1, 3 to the power n is equal to 2. To n is equal to 2. N is equal to 2. N square minus 1 is equal to 9 minus 1. N is equal to 2. That is equal to n cube. If n is an odd integer, prove that n square odd integer. This is not possible. We have to take n is only odd. Suppose n to the power 1 minus 1, n square minus 1, n is equal to 1. N is equal to n square minus 1 if n is equal to 1. So 1 to the square minus 1 is equal to 0, divisible by 8. Let n is equal to 2. N is equal to 2. Divisible, prove that divisible by 8. If n is an odd integer, prove that, suppose n is equal to 3. N is equal to 3 square minus 1, that is equal to 8, divisible by 8. Suppose n is equal to 5. So n to the power 5 square minus 1, that is equal to 24, divisible by 8. But it is a general formula. How will we prove this? It is a particular when n is 1, n is 3, n is 5. We verified that everywhere it is divisible. 0 is divisible by 5, 8 also divisible by 8, 24 is also divisible by 8. But how will we generalize it? This is the formula is told here, or the proof is here. Since n is an odd is given, we can express n is 2m plus 1, that is the standard formula for any whatever the m, it may even or odd. When 1 is added, then the number is automatically odd number. Then n square minus 1 is 2m plus 1 to the whole square minus 1, that is equal to a square plus b, a plus b square is equal to a square plus b square plus 2ab minus 1, that is equal to plus 1 minus 1 cancel, the remainder 4m, m plus 1. For any m, even or odd, out of two consecutive number, one must be even. So whether it is m is even or it is odd. If it is even, this will be odd. If this will be odd, this will be even. Suppose m plus 1 and m plus 1, two numbers. Whether any one of them will be even or not? Yes. If this is even, it is okay. It is odd. If this is odd, this will be even. So either when two consecutive numbers are there, on one number must be even. It is also very known to you. It is not a deep study is required or deep thinking is required. It is obvious. 1, 2, 3, 4, 5, 6, 7, whatever the tag, any two consecutive, one number must be even. If you are taking 3, 4, 4 is even. If you are taking 4, 5, 4 is even. If you take 5, 6, 6 is even. So this is the case we have used here. So 4 into even number, what will happen? 4 multiplication is 4. Again, if out of this one is even number, so even number factor is 2. So 4 into 2, what means? Is 8. 8 is again a factor. For any m, even or odd, out of two consecutive number, one must be even. If m is odd, m plus 1 is even. If m is even, it is okay, nothing to say. So then m into m plus 1 must be an even number always. So this number is always an even number. So for m plus 1 is equal to 4 into an even number, which is always multiple of 8, because 4 into 2 is equal to 8 into something. So it is a multiple of 8. Clearly n minus 1 is divisible by 8. Okay, it is the general proof. Another question number 13. For any positive integer n, prove nq minus n is divisible by 6. Let a is equal to nq minus n. You factorize it. Take common n. N is equal to n square minus 1. That is, it is again 1 is 1 square. N square minus 1 square. A square minus b square. A square minus b square is equal to a plus b into a minus b. A plus b into a minus b. Now just you rearrange it. First take is n minus 1, then n plus 1. Is not it 3 means product of 3 consecutive number. N minus 1, n plus 1 are 3 consecutive number for whatever n. N is a natural number or integer, whatever that may be. It is always a 3 consecutive number. Integers where n is greater than equal to 2, for n is equal to 1, nq minus 1 is 0 is obviously divisible by 6, means product of 3 consecutive numbers, integers. Where when n is greater than 2, why this aspect is taken when n is greater than 2? For n is equal to 2, for n is equal to 1, always it is 0. For 1 cube is 1, nothing to prove. Okay, so divisible by 6, it is obvious. Now just to take either 2 or greater than 2. Divisible by 6. How will you prove this? For n is greater than equal to 2, n minus 1, n plus is always divisible by 6. Because we have seen that it comes in the 3 consecutive number form. This is nothing but a product of 3 consecutive number. And we always know that product of 3 consecutive number is always divisible by 6. So this number is divisible by 6. So what aspect you used here? You just factorize and get this is the product of 3 consecutive number. And product of 3 consecutive number is always divisible by 6. You take any number. 2 into 3 into 4, it is divisible by 6. 3 into 4 into 5, it is also divisible by 6. 4 into 5 into 6, automatically divisible by 6. 5 into 7 into 8 into 9, it is also divisible by 6. 3, 2 factor, it is 2 and 3 factor divisible by 6. So it is in common. Any 3 consecutive number is always divisible by 6. So this number is always divisible by 6. The only thing you work out here is that this is the product of three consecutive number by the method of factorization and using the formula a square minus b square is a plus b into a minus b, and using your general very common sense that the product of three consecutive number is always divisible by 6. Prove that root p plus root q is irrational where p and q are primes. So we know that root p is prime, if p is prime, q is prime, root p is irrational, root q is irrational. Prior to that, we have read irrational, later on we will prove this. Prove that root p plus root q is irrational where p and q are primes. By contradiction, we will prove this one. In future, in the next some few chapters, we will that when two irrational numbers are added, it may be rational or irrational, but the question of p and q, if p and q are both primes, then it will be irrational. Take 2 plus root 3, 2 minus root 3, it is irrational, it is also irrational, but their summation is 4, rational. But this is not prime. This is not a prime number. This is not a prime number. It clearly given that p is prime, q is prime. Only when p and q both are primes, then root p plus root q is irrational. Otherwise, any other number, any irrational number, not necessarily prime, any irrational, there some may be rational or some may be irrational. It is equal to 4 plus root 3 plus root 5, irrational. Now prove. How we have proved this? By contradiction. That is the only process to prove all these problems, so which is rational or irrational. Let root p plus root q be rational number and say a belongs to q. Here the rational number a is not taken as p by q, not taken in the form of p by q for convenience. For convenience, we have taken here a. We can take a maybe p by q for no matter. Suppose a is equal to 3 by 4, no problem. It is also rational. We have taken that a to be a rational number. Then root q p is equal to a minus root q. Just take this to this a minus, squaring both sides. This is the process to prove all these things. A square plus b square, root q square is q, 2ab, 2a root q. Always try to select an irrational number and prove it rational. Yes, okay. So take this to this side. This is rational, taken as belongs to rational. P is a prime means rational. Q is a prime means rational. You take to one side. This is to be proved irrational, so take it to other side. 2a root q is equal to a square plus q plus p. This implies only leave this because it is to be proved that irrational. So take root q. Root q is equal to a square plus q plus p divided by 2a. Now what is this? A is a rational, square is also rational, q is a rational, p is a rational, 2 is also rational, and a is not equal to 0. It is obvious because this is not given, because a is equal to root p plus root q. Root plus root q is not, 0 is given. If it is 0, nothing to prove. 0 is nothing, rational, irrational, positive, negative, nothing. It is just a number. Whole number, it is included in 0. 0 is included in whole number. So any rational number, you add, subtract, square it, divide it, always it will give a rational number. That is the very fundamental aspect of a rational number. In higher classes, you will read about the closure property and the associative property, all these things. This comes under the closure property, means it is closed inside this. Whatever you do, you add, you multiply, you divide, always it will be a rational number. Rational number yields rational number. Only division by 0 is meaningless. The divisor should not be 0. Only one restriction. It is also obvious. A is not equal to 0. So root q is come to as a rational number. Thus right hand side has numbers. Right hand side has a square, q, p and 2a. Since all these numbers are rationals, a square plus q minus p by 2a is also a rational number, as a is equal to root p plus root is not equal to 0. This respect written here, it is given, it is not equal to 0. Implies root q becomes a rational number, which is wrong. We have taken, by contradiction, we will taken this to be a rational number, and we arrive at that q becomes a rational number, which is not possible because q is given prime. So any prime root over is always irrational number. So we are taking this to be a rational, we come to a contradiction. So what will happen? This will not be rational. So p plus q is irrational. So this is the proof.